Okay, let's take all of that information and put it on a graph. So first thing I want to put on there is the vertical asymptote at x equals 3. Remember, an asymptote is the line that the graph never actually touches, so I'm going to put that in there dotted. Then I have the horizontal asymptote at y equals 0. Well, that's the x-axis, so I'll just put some little dots at the end here to show that that's going to be an asymptote. Now I need the whole at -1/2, -2/7. Just kind of estimate where that's going to go. That's an open circle. There's no x-intercept, so I'm not going to put anything on the x-axis. And on the y-axis, I'll put a dot at -1/3. It's going to be about there. Again, we'll just estimate that. Okay, so let's consider the part of the domain that's to the left of the vertical asymptote. I need to determine if I should be above the horizontal asymptote or below. Well, I have these 2 points down here that I need to be able to go around and go through with my graph. So that means I'm going to need to be below the horizontal asymptote. So remember, this goes on and on forever in all directions because the domain is everything except -1/2 and +3. So there we go. It's going on and on forever, both to the left and the right. It should not touch the axis there. It should stay below it. Sorry about that. Now, on this side, on this part of the domain, I need to know again whether I should be above or below the horizontal asymptote, and there's really no indication of which way I should go. So I'm just going to select a point. I'll pick 4, and I'll substitute in. I could substitute into the original function or to the canceled function. I'll choose to substitute into the canceled function because that's simpler. Putting in 4, I get 1/1, which is 1, so I have the point 4, 1. Let me put that on there. Well, now that I have a point here above the asymptote, I know that the whole thing needs to stay above the asymptote. Again, arrows on both ends, going on and on forever in both directions. Staying above the asymptote, not touching the axis there. So there's my function. So let's look. If you see this on the calculator, notice it could be a little bit misleading. If your calculator's like mine, it looks like the function stops here and here and here. The calculator just doesn't handle asymptotes very well. So you have to be smarter than your calculator. You have to look at this and realize that's not really what the function looks like. That's really what the function looks like, going on and on forever in all directions.